I mean, I hate to interrupt that song because that's one of the best songs in the track. But we should probably get started with chemistry. Hi, everybody. I hope you're having a good Tuesday afternoon and that your weekend was relaxing. And then you got a bunch of stuff done. I went to the campus on Friday to record that lab video that you may or may not have seen yet. If you haven't yet, that's okay. Don't worry about it. And it was very, very strange being on a completely empty campus in a room that nobody has been using for, goodness, I don't know how long it's been since anybody's been in that lab. But you can imagine that that's where we would be if there wasn't a pandemic going on. That's about the best that I can hope for. It wasn't actually dusty, probably because there weren't any people in there to make any dust. Most dust is just like dead skin cells and stuff. And all the doors would be closed, so there wouldn't be much stuff to get in there. What am I clicking on? I'm clicking on this one. And then I'm clicking on this one. There we go. Excuse me. So we are going to do math today. I hope that over the weekend, at some point, like an hour or two, of practice is fine. That you went over the sig fig rules and know how to use them to figure out how many significant figures are in numbers as written. Because we're going to use those again today when we do math with them. Because the whole point of sig figs is to imply error. How much error is in this number that I've given you with no other background? You have to figure out the background from the number as written, and that's what the rules help you devise. Now we need to use that information to answer simple problems, and then later on we'll answer more complex problems. So I'm going to give you like elementary school problems to do today. And then we're going to do them wrong because we've never actually considered the idea of error in doing math because we've always just considered numbers to be these absolute discrete quantities. But in reality, that's not true. So on the left, you'll see here on example A, I had to add these numbers together, and that's trivial. You could punch that in your calculator. You could do that by hand. There's nobody taking this class or watching this video right now that can't do that. I am certain of that. Same thing for B. You just multiply the two numbers together to find area. Like, we can all do that. But how do we report the answer to consider error? And we're going to look at these two examples to show why we have to be careful about that. So let's start with the addition problem. If I have a bunch of numbers lined up vertically, in the past, we would consider the numbers to be just discrete values that ended on whatever decimal point they ended on. So, for example, if I wrote 352.8, I keep clicking on the wrong pen. Hold on. There we go. If I wrote 352.8, what I actually meant was this. So, like, when you were doing addition in elementary school or Algebra 1 or whatever, and you see a number, and the number stops at some place, all the remaining numbers are implied to be 0. But if this is a measurement, that's not necessarily true anymore. In fact, what the additional numbers become instead, that's still the wrong pen, there we go, are more like this. I don't know what these numbers are because when I used a ruler, I only had markings for every 1 centimeter, we'll say. And I estimated the next number to be 0.8. It was 0.8 of the way between the centimeter marks. But I don't know the rest of the numbers past that. They're all question marks. Now, if you are doing the addition and you were in, say, 4th grade or 3rd grade or whenever you did this, I don't know, you would just treat these blank spaces as 0 and add straight down. And you'd say, well, 0 plus 1 plus 0 is 1. 0 plus 8 plus 4 is 2. 8 plus 6 plus 4 plus the 1 from over here would be 9. I guess I should carry the 1s here. 12, 15, 13, 5. There we go. And so you'd get this number just by adding vertically. But, and let me see if I can actually make it do what I want to here. I can't, but that's okay. I'm just going to do this. This is me trying to highlight the thousandths place. If I were to add those 3 numbers together, 1 plus question mark plus question mark, would I get 1? What would the result of the highlighted column be? And yeah, I know it's Tuesday. Did I say Monday? I thought I said Tuesday. Can I write a 1 there in that highlighted spot at the bottom, doing this math problem, knowing what I know about how measurements work, that last digit could be anything? Yeah, it'd be like x, right? 1 plus x. So this could literally be any number down here at the bottom. So, because... Oh, my stream name is Week 1 Thursday. Okay, hold on. I could fix that real quick. I didn't edit any of the info, so let's see here. Edit. Week 2, Tuesday. Finishing Unit 2. Yeah, that box used to pop up. If you refresh the page, it should tell you the correct stream title now. So, for our purposes, when we're doing addition, and we have these blank spaces because we don't know those numbers, question mark plus anything is still question mark. So any place that I have a question mark in, I'm going to have a question mark in the answer. But right here, now all the numbers are known in this place. And so what that means is that's where I'm going to start writing my answer from, going to the left from the most precise place to the least precise place. Now, how do we make a little mnemonic to remember this? And the answer is that when we do the addition, we're going to look for the first place that has all digits in it and no blanks and no unknown stuff. So what that means is that when we look at these problems, you're going to have to set up the values vertically, at least until you become proficient at this. So what that means is that when you put the problems vertically like this and you... Oops, that's not what I meant to do. And you line up the decimal places like this and you do the addition, the first position, going from the right, so you start here, and you look at each spot. Is there a number that's blank? Is there a question mark? If there is, you move to the next one. There is, you move to the next one. Oh, here we go. This is the first spot where there isn't one. And then, once you've identified where you're going to round your answer, which is going to be that position there, the 10th place, then you just add the numbers on your calculator like normal. So I would just add all these together, and there's the number that we got before. But because these two numbers over here have question marks in them, we're just going to omit them. Now, instead of omitting, what we're actually doing is rounding. So if you had 5 or higher in that first digit you dropped, you would then round up. But that's the number you would report for this answer. Because one of your values only goes to the 10th place, for that value, we don't know the hundreds place right here or the thousands place. That means that any other number we add to it is just going to lose those numbers because it could be anything in those positions. But the remaining places are well enough known that we can rely on them. Now here's a question that comes up a lot when talking about numbers here. And that's the question right there, is what Chris is asking. So, hey, what happens if we have to carry over a number from the numbers that we deleted? Well, first of all, these numbers are known, so they can still influence the number here. Second of all, let's suppose that I had like this. I had a 1 and a 3 instead. And then that meant that this became a 4, and then this would round down to 8 or something like that. Or it wouldn't round up to 9. Since I'm only 1 off in the last digit, if these are very small, it's still reliable. Because remember, we're estimating the last digit. So there's always going to be inherently some error in that last number based on what the value of the other numbers in here is. And the more numbers that are in there, the more reliable it is, because you know more numbers, obviously. So any numbers that are in here, we're going to keep their effect. So even though we carried the 1 and then eventually just dropped that position anyway, that's okay, because those two numbers were known already. It's just we added them to some unknown blank quantity. And the odds are that this is a number that's going to be less than 8, so this won't be a 0 and a 6. So this is the best estimate that we can give. We'll never know it for sure, but it's close enough. All right, let's do some more examples of these. So the first question that we want to ask is, what is this number here using these rules? And that's not supposed to be there. I loaded the wrong thing. I made that this weekend. That's for Zelda. That's my Moblin. He's holding the Triforce. Where is my lecture setup there? I just opened the first thing and didn't even look at it. Is that... Oh, this isn't centered correctly. Hold on. You get to all see my happy Moblin. With the Triforce, because that's what he found. And now I can't see the problem because my OBS is behind this. New layer. Yeah, that's right. Okay. I need the paintbrush tool. That's kind of a thin line. Hold on. Oh, it's 1 pixel wide. That's why, because I was painting a pixel art. All right. If I'm going to do subtraction, I got to line everything up vertically like that. And then this color's a little too bright, so let's do that. There we go. Which position will I round to? Well, if I start from this side, do all the numbers in the hundredths place have a known value? Well, no, there's a question mark here, so that's not going to work. Do all the numbers in the tenths place have a known value? Yeah, we know both of them. Excuse me. Okay, so I'm going to round to the tenths place. We'll do the subtraction like normal, so 4, 0, 7. I'm going to round to the tenths place because that's what we decided. And then we'll round our answer as appropriate. Oops, that's not what I meant to do. That's what I meant to do. Because now when I do this, that didn't do anything. There we go. Now when I do this, the answer should show up. All right, easy enough. Let's do another one. Oh, that didn't click. All right. What about this problem? Oh, my Photoshop messed up. There we go. All right. What is this sum? So let's put the numbers down. 139.228. All right. And now we got to do the same thing. We got to find what place we're going to round to. But numbers that don't have decimal places are actually inherently trickier. And the reason for that is because, remember, rounded zeros that are placeholders aren't known. They're placeholders, right? So if I start over here and I'm like, does this position have known numbers? No. Does this position have numbers? No. Does this position have known numbers? No. Does the ones place have known numbers? This is my decimal point. And the answer to that is no, because these zeros are placeholders. So the tens place is equally no good, but the hundreds place is, so we would round here. Which means that when we do the addition, 7439228. Uh-oh. I must have been holding the undo button on here. We would then round to the hundreds place and get 7,400 as our answer. And that already is probably sounding bizarre to you. Like, what the heck is going on here? Why am I losing so much information that we've been doing before? And it's only going to get worse. Here's our next problem. What happens when I add these two numbers together? Well, we do the same thing. Do I know all the numbers in the ones position? No, because this is a placeholder. This is a placeholder. This is a placeholder. Which means that I'm going to round to the thousands place when I report my answer. So in this class, 3,000 plus 6 is 3,000. And you're looking at that and going, what the I had to censor myself there. I almost expletived on the internet. Oh, I'm going to do it at some point. Like, what the hell? Obviously, there's a 6 there, but where did the 6 go? And the answer is, well, we don't have that information because the random value of those placeholders messes up the precision of the 6. And here's how we're going to show that. We're going to use sort of realistic realistic examples to indicate why this numbering or methodology of adding and subtracting makes sense in reality. Let's suppose that you decide that after this lecture that it is extremely frustrating to deal with significant figures, and you decide, forget it, I don't want to be a student anymore. I'm going to just go buy lottery tickets. And you get really lucky. The first time you play the lottery, you win $656 million. So this is how much money you now have. But you're new to this millionaire thing, so you celebrate in the only way that you know how. You go to Burger King and you buy a Big Mac for $7.99. How much money do you have left? Do you have 655,999,992? Or do you have $656 million? Because those digits are the important ones, and you don't give a shit about these digits anymore. You could drop $1,000 and be like, I still have $656 million. You could drop $10,000. You could drop $100,000. Doesn't even affect your bottom line. This is what we call Jeff Bezos. You could just throw tons of money. Relatively speaking, for like us, this is tons of money. And it doesn't affect the amount that you have, because these figures down here, it buffered when I swore. That's the power of my cursing, is I make the internet bitrate go down or something like that. These numbers down here are very precise. But these numbers over here are very imprecise. When you add a number that's precise to a number that's imprecise, you lose all that precision. And it doesn't affect the bottom line if they are too far apart. Can I scroll this up? Oh, I turned that feature off, so I got to do it this way. My tablet had a feature where I could just put my hand on the tablet and then like slide it up or put 2 fingers on it. I think I kept doing that on accident, so I turned it off. What is the population of Seattle? I just looked this up for a practice problem, and I don't remember it. We're just going to make it up. So we'll say that the population of Seattle is 820,000 people. This weekend, my friend Doug moved in to Seattle. What is the population of Seattle? Is it 820,001? No, because we don't know what these numbers are. Because this is all just an estimate, right? So sorry, Doug, even though you do count towards the population, this is still what we're going to be reporting the number as. When you add and subtract numbers that are vastly different levels of precision, you get weird results. Here's a visual example. Remember before when we had like a bin where I said, okay, here's 100,000 things in it, and then this would be 0. And I've had, I don't know, we'll say this much stuff in it. And I said, go ahead and estimate how much is in there. And you said, oh, it's about 40,000. Let's suppose that I add 10 more things into here. There we go. Did I affect the number on the scale? No, it's too tiny. That number is too precise relative to the numbers that we are working with that we have a scale to measure. Okay? So when you look at two numbers and you add them together and you're like, that result doesn't make any sense. Like, what the hell is going on? That's because we have trained you to look at numbers as discrete entities. Any number that I give to you that isn't in a science class is going to just be an absolute value. All the decimals that come after it are zero. But in science classes, all of the numbers that come after the last written digit are unknown because these numbers are measurements and we have to treat them as such. Okay? So whenever you're doing addition, make sure that you are following these addition rules because they are the rules that we will be following when we do science in this class and any science class beyond. Any questions on how we did addition and subtraction? Let me know in the chat. Can we do another subtraction problem? Sure. Let me find this. And then I got confused on where I was clicking. There we go. Let's just get... Oops, I'm out of space. So we'll just select all. And it's gone. Are there any math classes that follow this? No, because math does not teach you science. It teaches you math. Math is a philosophy, believe it or not. Even though we include math in, like, our departments, you might actually hear the term science and math, because math is not a science. We don't explore stuff in math. We do philosophy, like we prove things, and it's all based on logic and a set of principles that we establish at the beginning as definitions. So if you go to, like, say, your Algebra 2 class in high school or your calculus class and you add these numbers together, your teacher's going to look at you in one of two ways. One, he or she is going to think you're insane. Or two, he or she is going to say, oh, you've taken a science class. You've taken chemistry or physics. So let's do another subtraction problem. 535 minus 8.178. We'll just do that. And I'm going to give you some examples for you to try in just a little bit, but I'll do this one again on my own to help you. So first step, start from the right and find the first position that has a known number in all values for that position. So here we'll look at the, oops, that didn't work. There we go. We'll look at the thousands place. Nope, that's no good. We'll look at the hundreds place. Nope. Tenths place. Nope. Ones place. Yeah, that works. So let's do the subtraction as normal. So that would be that, 2, and 5. There we go. I think that that's right. I do mental subtraction really quickly. Now we got to round our number to the correct position. That's going to be the ones place, which we decided. So we would report this number as 527, because this 8 we would round up. Just an FYI, your text might say something about bankers rounding, where if you have 5 or higher and the preceding number is odd, you round down. Or something like that. Don't worry about bankers rounding. Bankers rounding is responsible for the economic crisis of 2008. It's not, I'm just being silly, but statistically speaking, we do not work with a large enough number of samples for bankers rounding to be meaningful. If you're in physics and you're doing 100 trials, then yeah, it'll be statistically significant. Lisa, can you be more specific on your question? Sorry, I guess I don't understand what you mean by the subtraction part. How do I get this answer? So what I would do is I would first. So remember that we're doing these in 2 steps. So the first step is to find the place. Oops, I hit the eraser again. So remember that the first step that we're doing is we're trying to find which place has the known digit for all the values. So remember, these arrows represent places. So this is the thousandths place, hundredths place right here, tenths place, ones, tens, hundreds, and so on and so forth. So those are what places are. We have to find the first one that has a known digit. That means it can't be a blank. It can't be a 0 that's a placeholder. It has to be a sig fig. So that ends up being the ones place because I have blank numbers here. I don't have sig figs here, so I don't know them. And then the second step that we're going to do is we're going to subtract like normal. So when you do the subtraction, right here, these numbers are unknown, but we need to be able to do subtraction. So what we're going to do is we're going to just treat the subtraction like you've normally been doing subtraction all along. So what that means is punch this in the calculator and just hit enter, and then the number that comes out should be this. So you're going to treat these blanks as if they were 0 when you do the subtraction part. So that's what I mean by subtract is normal. Do the subtraction like you have normally done all this time. Because whatever numbers you get down here, you're just going to drop them anyway. And then finally, you truncate to the position that you selected. Oops, I gotta round that. Isn't 535 an exact number? No, it's not, because 535 with a dot just indicates that all of the numbers are significant invoking the decimal rule, and that any written numbers to the right of it would also be sig figs. Now, if I wrote this, that 0 would be significant too, and so on and so forth. But because I only wrote 535, oops, that eraser's way too tiny. Oh, I hit the wrong thing. There we go. It only has 3 sig figs. It's not an exact number, so be careful. It's only an exact number if I tell you specifically that it's an exact number, that it was counted or something like that. Okay? You should, whenever you look at a number, treat it as inexact. Now, how do I communicate that a number is exact on an exam? I usually do this, and that's not the pen tool. There we go. So I will usually, oops, there we go. I will usually write something like this. An underlined number is exact, and so I might say 480 plus 29.28 minus 6, and then I'll underline the number 6 or something like that. And what that means then is that if the underlined number is exact, then that you know this about it. Which means that when you line this all up vertically, those zeros go on forever, because that's an exact number. And so it's never going to influence your sig figs, because you're just going to have a bunch of zeros that are known. And then you would do all the lining up like you would do normally, and all the other numbers would affect it. And you're going to see a few of those later on, too. All right. That's addition and subtraction. Let me know if you have more questions, because I'm going to give you a few of these in a little bit. Oops, that's the title card. I want this one to do. But I think we're going to do the multiplication and division first before we do that. So this is problem B from that first slide that we talked about earlier today. And the goal of this problem is to find the area. How do you find area? Well, you just times the length times the width together, right? So area is length times width. So I would take these two numbers and I would multiply them together. Now, if I had used the same tool to multiply both of these things together, you would notice that the first value goes down to 4 decimal places, so the 10,000ths place, that's right here. My second number right here only went to the 10ths place. Now, if I was multiplying two numbers together with the same places, then what I end up doing is I do this sort of thing where I write down numbers, I do the multiplication, and then I like put an X here. And nobody has done this since like 3rd grade, right? And then you do this. Nobody does long multiplication, right? And so you just keep doing that, and then you add everything together when you're done. We all sort of remember that. Like, long multiplication, that's not a thing that exists anymore, is it? And it totally is, and we're not going to do it. But what I do want to say about the long multiplication is that if I were to do it this way, anything times question mark would still be question marks. So these are all question marks. And then you keep doing that for however many times you're going to have all these question marks in here. Because there's 3 numbers, so the first 3 rows are just completely unknown. And then for the 4th row and onward, when you start multiplying 14.2985 times 6.4, you're going to end up... Oops, wrong color. So here's my blanks that we'll fill in. I'm going to have some numbers here. I don't know what these numbers are. I'm just going to do that. And you'll notice that I'm going to be in the same situation again where I'm adding all these question marks together. And I'm just going to get question marks when I do this. So only numbers from this spot onward are going to count. All of the other numbers over here are lost because I got just a bunch of question marks in there. So if I do this problem long multiplication-wise, I will eventually get an answer that I'm only allowed to keep the numbers from that position and leftward. Everything that's more precise is a question mark. Now, that's the theory behind this. We're not going to do it this way because it would take forever and you'd have a bunch of question marks all over the place and you'd go crazy. So there's an easier way to get to the result of this. And that is to look at the precision of your numbers in terms of how many places they encapsulate. How many sig figs is this number? 14.2985. How many sig figs does that have? 6. Very good. Okay. How many sig figs does 6.4 have? It's got 2. Excellent. Okay. What we're going to do is our answer is going to have the fewer of the sig figs that the digits that make it up have, or the values that make it up have. Which is fewer, 6 or 2? Well, that's this one, right? So what that means is that my answer, when I multiply these two things together, should have that many sig figs. So I'm going to punch this in on the calculator. 14.2985 times 6.4. And what the calculator spit out for me was 91.5104. Now, what does the calculator do? It's treating those question marks as 0. And it's just doing all the multiplication that way. And that's fine. But now what we're going to do is we're going to round our answer to the fewer of the 2 sig figs. 2 is fewer than 6, so I need this number to only have 2 sig figs. when you are selecting the sig figs that you keep, you start with the first number on the left and you go to the right until you got them all. These are the 2 that I would keep, so I'm going to round to that number. Now, this 5 makes me round up, so this is the answer that I would report. So that's how you do multiplication. Let's go over the rules on the next slide one more time, but I'll give you a second to write all that down. All right, so here again are the rules. Whenever you do multiplication or division, you want to look at the number of sig figs in each measurement. Of those measurements, choose the one with the fewest sig figs. So again, we said that there were 6 on the top number and 2 on the bottom. Your answer will have the fewer of those sig figs. So there's our number, but we decided it only gets to have 2 sig figs based on 6.4. So I round it to 2 sig figs. Now you're probably looking at this and going, wow, that's way easier than addition and multiplication. Or, I'm sorry, addition and subtraction. And you're right, multiplication and division follows an easier rule. But the most important part about this whole discussion here is the following. Addition and subtraction and multiplication and division have different rules. Okay? And that's the most crucial part. When you are doing these practice problems, it is super tempting to just take the multiplication rule and apply it to everything. And if you do, you get the wrong answer anytime addition is involved. So you do have to learn 2 different sets of ways to treat numbers. Be careful. Don't use the wrong rule. Or you get the wrong answer, and that's no good. All right. What happens if you have to do both things? So, for example, what is the correct answer for this calculation? If you punch it in your calculator, I got 1.0674499792. How many of those digits do I get to keep? And you might immediately be jumping to like, oh, well, there's only 3 sig figs in 73.8, so it must be 3. And that's how I get you. Okay? Because there's addition and subtraction, you can't just do the let's count the sig figs thing. If there was only multiplication and division, then sure, you could use the multiplication and division rule. But because there's addition and subtraction, we have to use the addition and subtraction rules too. So let's do these problems together. I got to do this. All right, and you can see here on the screen while I expand this, we're going to do order of operations. PEMDA. What does PEM, what does that mean? What does that tell you? Yeah, this is what is known as the order of operations. It's please excuse my dumbass sister, right? Or sibling or whatever. No, that's not how it is. It's please excuse my dear Aunt Sally or whatever your notation is. But P is parentheses. E is exponents. Multiplication and division And those are actually ranked together. And then addition and subtraction are also ranked together. And so this is the order of operations. Whenever you see a problem on the board, or in your book, or whatever, and it has these functions in here, you have to do them in this order, or else you get the wrong answer. For example, if I tried to divide first, and then I did the subtraction, it wouldn't work. The reason being is that we have decided as a society, this is the order that we're going to do math, so that we get the correct answer every time, we get a consistent answer. Okay, so let's take this number here. I don't know why it's like that. There we go. 73.8 minus 70.983. In parentheses, divided by 2.639. And my little dot didn't show up. There we go. All right, what's the first operation? It's the parentheses, which means that we're going to have to do what's inside here first. That's a subtraction, so I need to set it up like a subtraction. So we're going to do that down here. 70, oops. I messed up. Erase. 73.8 minus 70.983. So I want you to do the subtraction for this first step and type the answer in the chat when you have the result for this number. Use the correct number, Sig Figs. So let me know when you got it. And then I will do the problem with you. And then we'll go to the next step and talk about what we need to do. I'm just sitting here drinking water because I'm dehydrated. All right, it looks like we all agree that this is the position we're going to round to. So I'm going to do the subtraction. And now that I've done the subtraction, did I do the subtraction right? Yeah, that looks good. I'm going to round to that position, and I will report this as my answer. So what that means is that the number on top of the parentheses, oops, is 2.8. So we're going to substitute that in there. 2.8. Now, you're not fooled. That's what we're here for. We're here to learn. If you knew how to do this, I wouldn't have a job. So I'm grateful that you don't know how to do it, because now I can be paid to teach you. Which means I get to eat things like tacos and salad. I don't know. Now I'm hungry. Anyway. We did the top part. Now we can do the entire problem, because the next step would be division. So what is 2.8 divided by 2.639? Well, I'm not going to do the long division. Your calculator can do that for you. So you punch it in, 2.639. And it spits out 1.06100798. That's way too many digits. But we're going to count sig figs here. So this is 2 sig figs. This is 4 sig figs. How many should my answer have? It should have 2 sig figs. So I have 1.061. That rounds up to 1.1. And that's the correct answer. So if you looked at this problem 73.8 minus 70.983 divided by 2.639 and said, I think there's going to be 2 sig figs at the end, then you're either psychic, cheating, or you know exactly what you're doing. Because I can look at this and know that there's 2 sig figs because I can look at the top problem up there and say, I'm going to lose the tens place. I'm going to have a number that goes to the ones place and the tenths place. So be very careful on exams when dealing with sig figs, because I'm going to ask you questions like, how many sig figs will the answer have? And if I ask you to add these 2 numbers together, and I say, how many sig figs will the answer have? And you might go, this is 3 and this is 5. And I'm going to go like this, so of course my answer is going to have 3. And then you do the addition. And then, and you're wrong. Because I purposely picked a problem that would do that. So, be very careful. Don't apply the multiplication and division rules accidentally to everything. Okay? Addition and subtraction screws everything up because it has to do with places and not number of digits that are known. Alright, so... Oops, I'm on the wrong screen on my end here. Hold on. There we go. And there you go. That's what we just did. So be careful when you're doing these types of problems. And I think the last thing I have here for a warning is a calculator warning. Oh, it's on the next slide. Okay, so what do you do with rounding? Well, we just talked about rounding. Rounding in this class, we're not going to do the banker's rounding. Mostly because, philosophically speaking, there's no reason to with like 2 or 3 data points that we're working with. If I were to type these numbers in my calculator and I only wanted 3 sig figs, how would I round them? Well, I have to keep the biggest numbers first and go down in this direction. So I'd keep these 3, and then I would round my answer. Since that's a 6 that's higher than 5, I'd round to 30.4. And here are the rounding rules, just in case you've forgotten. I don't think anybody's forgotten the rounding rules. That's pretty ingrained in our head. We've done rounding forever. Alright, and then the last slide we'll do before we take our break, because I'm going to save the practice problems for when we come back. When you use your calculator doesn't know what sig figs are. So here's a practice problem for you to try. What I want you to do is, if you have a calculator handy, put this in your calculator and hit enter, and tell me what the calculator answer displays. Type that in the chat. While you do that, I'm going to put this on the board here. And we're going to follow the sig figs rules. We're going to round to this spot because there's a digit in the thousands place. And when I do that, I get this. So I'm going to keep that as my answer. But what does your calculator tell you the answer is? Yeah, it just prints 8, right? 8, 8, 8. Now we're the Stanley parable. 8. So your calculator doesn't know what those zeros mean, or if they're important, because your calculator is programmed to put as many numbers on the screen that aren't 0 as possible, because it thinks that's what you want to know, and most of the time that's correct. But in science, we actually want to keep those zeros. We want this to show, hey, I know this all the way down to the thousandths place. That number is precise. I want this object to be made to these specifications. In fact, I think I've linked an article in the text somewhere about why sig figs are important. For example, if I wanted an object that had like an edge length of this many inches, And then I also had one where I wanted it to be this many. This one would be very cheap to make. This one would be extremely expensive because the amount of precision that they would have to put into that, because they would have to get within 1,000th. Whereas on the other one, they have to get within 1/10th. And if they chop it down too far and they go outside the precision, then they have to throw it out and start over. And so that's additional materials cost and time and labor. So the number of digits that you write down matters very much to people who work in science and engineering and also other industries such as manufacturing and welding and machining, we'll just say. Now, you can configure it into calculators, but what you oftentimes have to do is you have to tell it how many decimal places you want it to show. So you can do it on a per answer basis, but the short version of that is if you don't want to fiddle around with your calculator all the time, the best way to get around this problem is you can type numbers in your calculator, but do the sig figs manually. Always use these rules that we've talked about to do the sig figs and check them at the end to make sure you have the right number. All right, I think the next slide is the practice problems. Okay, so we're going to do that when we come back. We already talked about exact numbers. Exact numbers don't affect your sig figs because they have an infinite number of sig figs. They won't affect your precision at all. So let's go over here to the break card. I need a timer. There's my timer. So I'm going to put the music back on. We'll put more Zelda Wave on. We'll reconvene in 10 minutes, and then I'm going to have you do these practice problems. You can work on them if you want. They're in the slides, but we're at the point where it's time for a break. So I'm going to start this, and I'm going to start this. You can't hear anything because I haven't done the thing yet. There we go. All right, I'll see you in 10 minutes. All right, we're back. I wasn't really trying to line it up. I was sitting there listening to the music, like, oh, is the music gonna light up right at the end? And it totally didn't. So I was like, oh, I'm just gonna let it play through. Let me clear that out of here. That's fine. Oops, that's the wrong screen. All right, so now you get to do the problems that I have prepared for you. So I have these seven problems. And what I want you to do is use the rules for significant figures to determine the correct answer for each problem. I've sort of mixed in random rules here and there. So be very careful about what is multiplication or division, what is addition or subtraction, and what is combined. Okay? Just as a clarification, when you see this icon right here, this slash, that's division. because I can't typeset, so a slash is division. Okay. I prefer not to put music on while you guys are doing problems, and also we reach the end of the Zelda Wave track anyway. So I'm going to hit mute on my mic. I'm going to let you do these problems. I'll give you about 5 or 6 minutes to do them. When you have your answers, type them in the chat and compare your answers with the rest of the group. And then we will go over them together when I get back. Okay, see you in a bit. All right, I'm back. All right, so it sounds like a bunch of people are stumbling over just the decimal numbers that I have in here. So like this 0.0019. How many sig figs is that? So we'll go over those questions and more as we do these problems together. Where is my... I clicked on the wrong thing. Hold on. Boop. But that's going to be what... Oops, that's not what I want. Hold on. This is a little too small. Let's see if I can... We'll just do that for now. Okay. For a lot of these problems, the trick to doing well with sig figs and stuff like that is to practice, practice, practice. So if you did enough work and you remember the sig figs rules to figure out the number of sig figs in each of these numbers, then you're in good shape. But if you looked at that first number and you're like, oh, there's 5 digits written there, so it's 5 sig figs, and that's a problem. We got to go back and look at what those numbers are and what they mean. So, oh, darn it. Let me turn that off, and what is this? This can go away. I have a bunch of Photoshop panels that are popping up over my OBS, so I can't actually see the numbers. There we go. All right, so the first step is to count the number of sig figs in each of these measurements. So they're both decimals, so remember that whenever you have a decimal present, you find the sig figs, so these are sig figs. Any zeros that are to the right will be sig figs. Any zeros to the left will not be. The ones on the left are placeholders. And the reason that they're placeholders is if I did this, the value of that number changes. 19 is very different than 0.0019. We need those zeros there to make it have the correct place. But the zeros themselves don't change the value of the number itself. Like, the zeros have no value in them. It's just that their purpose is to push the numbers that do have value into the correct order of magnitude. So those zeros are not counted as significant. So this number will have 2 sig figs. Over here, these are all non-zero, so we're just going to count them all. That's easy enough. And then I got to do the multiplication. And my answer should have 2 sig figs, because that's the smaller of the two. So my calculator says 0.40641. And I'll write down all those numbers here. But now I got to round it to 2 sig figs, because that's what we decided was the smaller of the two. This isn't a sig fig, but we're going to just write it because it's a placeholder in a manner of speaking. 1 sig fig, 2 sig figs. And so we'd stop there and round up. There you go. And if you don't put the leading 0, that's okay. Yeah, you miss the live class, you miss out. Though I do realize that the course catalog didn't put this with a time because administrivia reasons. So, I understand if you can't make it here. But if you can, please come. I hope that it's useful. And if you can't, make sure that you ask me questions. So it's not 0.040641. Oh, I see what you mean. Sorry. Oops. Okay, hold on. I lost a 0 in there. Yeah. No, you guys have the right answer. I don't know what the hell I'm doing. And by I don't know what the hell I'm doing, what I really mean is I don't know how to read my calculator. There we go. So let me try that again. So we're going to keep the placeholders First sig fig, second sig fig. So that's where we're going to go. I apologize that I can't see the very obvious 0 that is on my screen. All right, that's the first one. Let's do the second one. So 8.321, and I'm going to write this like an actual fraction here. 4.1. I even said the 0, huh? I don't know where it went. All right, how many sig figs does the top number have? It has 4, because none of them are 0. This is 2. So when I get my answer here, my answer is going to have 2. So 8.321, 4.1. And I'm going to write down again all the numbers that the calculator says. 20295. And double check to make sure that I'm not forgetting any. So that's what my calculator says, but I only get to keep 2. And so that's the answer for number 2. I got to actually push control when I drag that box, because it won't expand otherwise. There we go. Okay. Where'd the stylus go? There it is. Lost in all the pens there. All right, for the third one, this is addition, so I'm going to do it vertically here. 3020.3 00009 and then add. Oops. So there's the result of the addition, but remember how addition works. Let's look for places. Is there a known value in every place here? Well, there's not. Not in this one either. Or this one. Or even this one, or this one, or this one. So, nope. 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 We would end up rounding to the thousands place here, because this is the first place where all the numbers are known. Now, when I say all the numbers are known, you'll notice that my dotted line kind of falls well before all the rest of the numbers. And when I say the numbers are known, what I mean is, yeah, I know what they are. They're 0. I have 0,000 and 20 and 0.3 or whatever. So it's not that you need a digit written in that spot. You need a known value for addition and subtraction. So since I'm rounding to the thousands place, this is the answer I would report. I don't know why I did that. There you go. All right. So I'm going to first start by finding out what place I'm going to round to. The hundreds place actually works because I have a number for both of those in the hundreds place. So we'll just subtract. I don't have to round because I'm already in the right spot. And so this is the number I would report. You'll notice that it has fewer sig figs than either of the numbers I started with. And that can happen in addition and subtraction. When you are multiplying and dividing, you will always have the same number of sig figs because you got to chop your number down to that. But if you're adding or subtracting and your answer changes orders of magnitude, you can gain or lose sig figs. So if you add two numbers together and the number result is over, say, 1,000, you gain the thousands place and you gain a sig fig. So that can happen. Oops, I gotta do these two. We'll just do these together. Let's go over here. All right, for this next one here, How many sig figs do each of these numbers have? Well, they're all decimals. So we use the decimal rule. This is a sig fig. Any zeros to the right also count. So this is 4 sig figs. Same thing over here. If I multiply two numbers with 4 sig figs, my answer should have 4 sig figs. So if I type this in the calculator, I get 12. But I need more sig figs because I know more. I know up to 4. So I'm going to go 3, 4. And that would be the number I write down for that problem. Now that looks really weird. Why would I do that and lose the thousands place? And the answer is that's how multiplication works. Multiplying 6.000 times 2.000 is not the same as multiplying 6.000 times exactly 2, because it's not exactly 2. It's a rounded number. And when we do the long multiplication, like I showed you earlier, we lose that last digit, it turns out. I don't know if that actually is all the digits. Oh, it is. Okay, there we go. For the next problem, I want to leave that one on the screen so you can see it. We have that times 0.00390. And we have to do order of operations, which means that we have to do this part first. So we'll set it up vertically. We'll round to the correct position, which should be, this isn't going to work, this isn't going to work, but this 3 will work, so we'll go here. Because the tenths place is the first place coming from the right, where there is a number in all the spots. Then we'll add, like we're doing it normally. And round to this position right here. So now I can take my new number, 42.6, and times it by 0.00390. And when I do that... Oh, I have the eraser end of the pen down. Okay. So when I multiply these numbers together, I get 0.16614. We already said that this number had 3 sig figs. This has 3 sig figs. So our answer should have 3 sig figs, which means that we're going to keep these numbers and report that. All right, the last problem is 52.5000 over 3.6 minus 11. All right, what operation do we do first? We're going to do division, which means I need to worry about sig figs. So this guy has 6. That's the worst number ever. There we go. That's better. 6 sig figs. This guy has 2 sig figs. So that means that the answer of this coming out should have 2 sig figs. So I punch in the calculator, 52.5000 over 3.6. I get 14.5833333333, which I'm going to round to 2 sig figs, which is 15. So this is what my calculator said. So I'm going to round that to 15. So now I have 15 in this parenthesis minus 11. And I can round to the ones place because I have a ones for both digits. So that's the answer this problem is for. So I see a bunch of numbers on here for all the answers that people got. And it looks like people were pretty hit or miss. Oh, when I scroll the chat, you can see the chat too. But there's all the numbers that people got. Minus 11. Yeah, everybody checks out when we get to sig figs. I'm going to have all the dislikes. I can't actually see that right now. All right, but that's how we deal with sig figs and math. And this is something that's never going to go away. You're going to have to use your sig fig knowledge to answer questions for not just the remainder of Chem 140, but also 161, 162, 163, and whatever. Seven plus 4. Did I mess up a math problem somewhere? Yeah, if I make a mistake, let me know. Problem 6. Seven plus 4 is a... Oh, no, I didn't carry a 1. Yeah, I have an issue. Okay. Yeah, you gotta let me know that earlier. Yeah, I always look at the chat, like, did I do the math right? Because I'm doing these in my head. Yeah. So we're looking at that right now. I did 7 plus 4 plus carry a 1 for some reason. Oh, did my chat log not update? Oh, that's weird. Oh, yeah, I have all these answers up here that I didn't see here. Yeah, look at that. That's weird. Okay. Yeah, I blame Google and YouTube for that. Okay, so we'll fix that really quickly. So this became 41.6, so this number up here is 41.6. And then 41.6 times 0.00390 becomes 0.16224. We'll just erase this part right here. This will change too. 224. 2. There you go. And that looks like it's matching with more people, which is good. All right. Apologies for that. Yeah, the solution to if the chat isn't working is to just type more chat. Eventually, it'll go through. All right. So yeah, make sure that you practice these because, again, they're never going away. I gotta find the right window. There we go. All right, that's the end of that section. There's one little last bit about scientific notation that we're just going to zip through really quickly because I think everybody is familiar with scientific notation. So writing numbers that are really big or really small becomes very tedious. If I want to write this number 37 times, I have to remember that there are 1, 4, 7, 10, 13 zeros here. And that's going to get ridiculous really, really quickly. We don't want to deal with that. My chat go all the way down. I'm just gonna do that. There we go. So now I know that I'm at the bottom of the chat there. Okay, so I don't want to write giant numbers like this every time. So what I have now is I have this. Oops, you're not actually seeing my cursor here. I have this term right here. This 10 to the 0. What's anything to the 0 equal to? Yeah, it's just 1, right? Anything raised to the power of 0 is 1. So if I take this number and I times it by 10 to the 0, I'm actually multiplying it by 1, so I'm not changing its number. But what I can do, and this is the theory behind scientific notation, is that if I move this decimal point to the left here, it's like dividing by 10. I get a number that's 10 times smaller. But if I change this to a 1, now I have a number that's 10 times larger. And the two neutralize each other, so I get the effect of keeping the number the same. So every time I move this over, this dot, I just increase this exponent. I can do the same thing going the other way. If I move the dot to the right, I can then decrease the exponent. So here we go. It took me forever to animate this, so I hope you appreciate it. Do 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 do. There you go. So whenever you move your decimal point to the left, this number goes up. So left goes up. And then what you can do is you could just chop out all the zeros to put your answer to however many decimal places you want to have the correct number of sig figs. So for example, if I wanted to write this to 2 sig figs, here they are. If I wanted 4 sig figs, I do this. In fact, scientific notation is the only way to write certain numbers with the correct number of sig figs. For example, if I asked you to write the number 5,000, and I said, I want 2 significant figures. My goodness. My handwriting on this pad sometimes. How would you do that? Because if you put a dot there, now it has 4 sig figs. And if you don't have a dot there, you have 1 sig fig. How the heck do you do it? And the answer is to do what you're doing in the chat. There you go. That would be 5,000 with 2 sig figs. Whoops, nobody saw me write a 2 there. Sorry, normally I do this example, I do 500. Alright, that's scientific notation. That's really all there is to it. This number, as written, has 1 decimal place. I think your text in the past used to say it had to have 1 decimal place. That's not true. You can have as many decimal places as you want. You can even have no decimal places if you want. So 50 does not work because 50 and 5,000 are not the same number. Because remember, I want this number to have 2 sig figs. But those are different numbers. If I owed you $5,000 and I paid you 50, one of us is very unhappy with that arrangement. And it's not me, it turns out. Same thing with small numbers. This is the width of a human hair in meters. That's a silly unit to work with. So I decrease the exponent when I do that. For numbers like that to 2 sig figs, would you round? Yeah, you would round that number. So these are the 2 sig figs you're going to keep. So I'm going to round. And then this is, again, the wrong magnitude. 55 and 5467 are not the right magnitude. So I had to put in the placeholders. This would be 85 micrometers, yeah. Now, of course, it depends on your hair. My understanding of my hair is that my hair is like the thickest thing ever. And so I don't know if that's actually the correct diameter of hair. I just found this number online when I wrote the slide a long time ago. All right. So there's our summary. Larger numbers, you move left and increase the exponent. Smaller numbers, you move right and decrease the exponent. I don't remember what it would have to be for that in kilometers. That'd be like 10 to the 8, maybe? I'm not sure. Let's see. 1, 2, 3, 4, 5. Yeah, it would be 10 to the minus 8 in kilometers, I think. Not that you should measure the width of your hair in kilometers. It seems like there are better things to do. You could do these numbers in scientific notation if you would like to. We only have about 5 more minutes in class anyway, so I'm just going to quickly go over these. But what we will talk about together before we go is how the heck do you type these in the Canvas? So when I write long numbers, the way that I space these out, I try and put a space every 3 digits if possible. So 3, 6, 9, 12. That makes it so much easier than going 1, 2, 3, 4, 5, 6. Oh, did I lose count? Whatever. Same thing down here. 3, 6, 9, 12, 14. And then down here, doot. So 3, 6, 9, 10, 11. And there you go. And then since these are measurements, we'll put the units on them, and you're all set. Now here's a question. How the heck do you type this into Canvas? Canvas is kind of weird when it comes to typing in numbers. And when it asks you for an answer with a giant exponent in it, what it's going to try and do, and let me see if I can find an example of this for you really quickly. Canvas. Let me log into Canvas. Let me see if I can find a problem that requires a number. So that I can show you this. Because this is going to become very relevant in a little bit because the quiz that's coming up will have this in there. Let's see here. Does this have math in it? Yeah, here we go. Okay. So how do I preview this? There we go. Window capture. I want this. So if I do that. So this is for a different class. Let me find the problems with math in it that want us to do that. Okay, so that's what I want to do. So I'm not trying to hide things so that you can't see them. What I'm trying to do is make this bigger. How long is... Okay. Whatever, there's text involved here. But what Canvas is going to want you to do when you type in numbers is if you try and do something like this and put spaces in there or something like that, it's going to reject that as a number when you do that. So what you need to do is if you were going to type in an exponent, so let's suppose that this was your answer. 3100000000000. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3.1 times 10 to the 11. What you can do in Canvas is you can do this. 3.1 E11. And then when you click outside of that, or hit enter, it should do something. Oh, depending on what application, I guess it doesn't actually update that. But it will recognize this as a number. What's capital E? Personally, I think that this is kind of a garbo way to represent it, because E is technically a number on its own. Gosh, I don't know why it's not doing that. Oh well. I'm gonna have to look it up. None of the numbers that I think I have given you require this for this quiz, because I didn't actually put any scientific notation numbers on the test. But when we start talking about the mole, which will be in chapter 9 and 10, or units 9 and 10, maybe a little later than that, because we've renumbered the units here. We will start using very large numbers, and typing in 20 zeros into Canvas is not something that you should do. I will try and tell you how to do that if necessary. Let's see here. What are you using to do that? I'm not really sure what you mean. Do you mean when I do this? Like resize the window? I thought I required a space for it to work. That's the way I see that display. I don't actually know. I'll play around with it. I'm actually trying to... I'm in a mode where I'm pretending that I'm a student. So I could hit submit, but it's going to just mark the answer wrong anyway. Well, let me just try that. So we'll just submit this. Oh, results are not displayed. Because I have it set to something else. That was just in an old class that I have going. So, okay. Never mind. So I'm using open broadcasting software, which is why I can do that. So I can turn things on and off. So, like, I could turn off... I don't know, if I just don't want to listen to you guys anymore, I could just turn the chat off. There it is. It's gone. So I can do whatever I want. I can do this. I can, like, woo, there I am. I can click between scenes here. I can change scenes. So, like, if we suddenly wanted to play Man, we could do that too. My stream that I plan. But, like, it's basically just like, oh, here's, like, a PowerPoint screen, and you can throw all your stuff on there. And then this is what the viewer sees on the stream. Which is why I use it, because on Zoom, I think you can only just ever see what's on my screen. And then you're just going to be sitting there watching me minimize windows all day, which is no fun. I will try and look into the issue with typing in numbers in exponential notation, because I know there is a thing about it on Canvas, and it's very strange that I didn't encounter it just there, because I expected it to. That could have just been an entry field and not necessarily a number field, though. So I'll look into that more. Currently, the syllabus quiz is the only thing in the gradebook. You do get to keep that point. It's 1 extra credit point. And you do not need to worry about exponential notation on the quiz, because I'm going to just ask you questions like you've seen today. It's all going to be, in fact, this slide right here. Can I get out of this? Oh, I guess I can't. Okay. Oh, because I'm in 2003. PowerPoint. There we go. This slide right here is going to be very important in terms of what should you study for the quiz. It's going to be I think 2 or 3 of the 10 points is stuff like this. And then the rest is like definitions or count the number of sig figs or whatever like that. Okay. And I think that's it. Oh, there's some slides here about multiplying and dividing with sig figs. Or not sig figs, but scientific notation. I mean, this will help you do mental math. So, like 10 to the 4 times 10 to the minus 2. When you multiply, you just add these numbers together. 4 plus negative 2 is 2. And if you do division, you subtract. So 5 minus negative 3 would be 8. So this result should be something times 10 to the 8. That's a thing that you can do. I'm not going to test you on that. Oops, sorry. But later on in the quarter, we are going to be working with really large numbers. In fact, here's a number that you're going to be using. What this would do is, when you multiply these two things together, this is a number that's used for water. This is the molar mass of water. This is the number of molecules in a mole. So this might be trying to tell you how many molecules are there in a sample of water that weighs this much, or whatever. So we will be working with numbers like that. So be somewhat comfortable with scientific notation. And if you have any questions about it, let me know. I don't think that anybody will have a serious issue with scientific notation, though, which is why we're just kind of brushing over it. All right, so that's Chapter 2, or Unit 2, noise warning. There's our happy word. There you go. And that's the end. So that's Units 1 and 2. If we go back to Canvas here, where's my... Oops. That's not what I meant to do. Cancel. If we go back to Canvas, which... Where is that window? There it is. Oh, that's really useful. Let me get that off the screen here. I need the left side. That's what I want. How do you find the quiz? So let's see here. That's not super big, but here, we'll go to courses. You're going to click on your course. And yeah, I do stream. I have a Twitch account. So this is section A, 2534. But everybody's section is more or less essentially the same. Actually, let me do this so that it's a little bigger. So how do you take a quiz? What you're going to do is you can either click on assignments or quizzes. They both do the same thing. If you click on assignments, there's a category called quizzes, and you can go to the quiz, which will open in 6 minutes. It's not available yet. I just set a timer. Or you can click on quizzes, and it's right here. The quiz will tell you what units it's on. If you start the quiz, you'll get this screen before you actually begin. You can't actually see the questions because... Oh, they're not even on the screen anyway. But you're going to get something that looks kind of like this. And this is basically just the rules for the quiz. And I just want to mention them on air so that you have them. You will need a calculator. So have the calculator handy and a pen and pencil before you start. Because once you hit go, the timer starts and you can't stop it for any reason. Time limit is 30 minutes. You shouldn't really need longer than 30 minutes. I do randomize the order of the questions, so your questions will be in a different order than everybody else's. And the questions that you get on each question are also randomized. So question number 5 on the default template might have 3 variations. And you could get any of those, and your friend could get any other one of those. But your question 5 won't necessarily be his question 5. You'll see the same 10 questions, but they'll be scrambled. Is it 10 questions? Let me see. It's actually 9 questions. When I did the preview of the quiz, there's a little bar at the top that tells you how many questions you've done. So you can know how many questions you have left to go. Unlike the syllabus orientation thing, you cannot backtrack on this quiz. Or any of the quizzes. So you're going to be given a question, and if you know the answer, great, type it in, solve the answer, whatever. If you don't know the answer, then you have to push next, and you have to go to the next question. After 30 minutes, the quiz does shut down. The caveat to that, not being able to get back, and your questions being randomized and all that, which does suck, I know. I had to do something on this quiz. The caveat is you can use any resources available, which I suspect is why somebody immediately has asked, has anyone started a Discord for this class? So if you need that, remember we have a discussion board on the Canvas page, and if you post something like that or somebody makes a Discord, let me know. I will pass that link to the other sections, or you can just paste it in here. YouTube might make me approve it, but that's fine. So you use any resources available on the quiz, but mind the time limit. So the time limit is what's going to really screw you if you're depending on going to Discord to find people who've already taken the quiz. Because it's only 30 minutes. So if you're sitting there waiting for somebody to try and tell you the answers for your specific iteration of the problem, which they may or may not have, you could run out of time. So the best way to avoid timing out is to know all the content, obviously. And again, remember, you get 2 attempts. So if you want to just use your first attempt to look through the quiz, like, sure, I don't care. That's fine. Keep in mind, your second attempt will be different from the first attempt. So your questions on the first time through will be one set of questions, and then the second set are totally randomized too. Okay? So be careful. Finally, when you submit your grade, it will tell you the instructor has hidden responses. It should tell you your score. If it doesn't, let me know. That means I've messed up hitting a setting or something like that. And that's pretty much it. The deadline for the quiz is October 5th at midnight. Or sorry, no, October 5th at 11:59, because midnight would be October 6th. So that's the soft deadline. That's Monday next week. So 6 days from now. On Tuesday's lecture, what I will do is I will say, okay, if you haven't done quiz 1, make sure to finish it. I'm going to close quiz 1 tonight. So then after we do the lecture, you'll have like an hour or two to go do the quiz if you haven't done it. And then I hit a button and it will disappear, and all the answers will appear, and everybody's scores will appear. It will put your score in the gradebook, I think immediately, but I'm not sure. Are there unit worksheets graded or recommendation? Those are just for practice. They're basically homework. I use those problems and the problems from the textbook and create similar problems in Canvas to the best of my ability. I can't do every problem in Canvas because what I can do is... I mean, there's a lot of things I can do, but it's kind of limited. I think that's it. I think that's all there is to the quiz. So, quiz number 1 should be really straightforward. Quiz number 2 will be Unit 3 in its entirety. So Unit 3 is going to take us a while. We're going to do Unit 3 on Thursday and also next Tuesday, and then probably finish it on Thursday, because there's a lot to do in Unit 3. And then after that, we're going to whip through a bunch of units really quickly. Like 4, 5, and 6 we're going to do in one day. Because 4 is density and 5 is temperature. Like, that's a day. And then 6 is the periodic table or something like that. So it might feel like we're kind of slogging through a few units right now, but the early units are really, really long, and then there's a big chunk in the middle where the units are just really fast, and suddenly we'll be on Unit 10. All of a sudden. Okay. It looks like somebody has made the Discord. Can you post the invite link for all the students who want it? It should give you a score immediately when you take the quiz. If it doesn't, let me know, because that's a mistake. Because I have them programmed in. I didn't see the link. How do I... Let's see here. I'm not going to make you a moderator, because you'll delete my channel. It should allow links. How about you email me really quickly? Email me the link, and then I will just paste it in here, because I can paste whatever link I want to. So yeah, we'll hang out on the stream for just a second until I get that email. Because that's obviously important. I do want you to have the class Discord. No, I will not join your Discord before you ask, because that's kind of a conflict of interest. And also, I want you to have a safe space away from me where I'm not going to look and see all of the nefarious things that you're doing. Because, one, I don't give a shit on some level. Like, you're students, you have agency, you should be able to do whatever you want to. And two... C number 1. I thought I had two answers there. Okay, there we go. So, copy, link, paste. Okay, that should work. So there's the link to the Discord. Yeah, you can make me like an unmoderator. And all I can do is sit in one channel that just says, talk to Dr. Wes, or whatever. Honestly, that might kind of work, to be fair. I'm still not going to accept an invite, but... Like, I don't want to see what's going on in your channel. I don't want to read about all the stuff that you're going to say about me. Like, oh man, he's such a jackass. Like, I don't need to read that. That'll just make me sad. And that's inevitable. At the end of the quarter, you're all going to hate me because that's what you do. You're students. You hate your instructor. And then 10 years later, you'll be like, oh, he wasn't so bad. And that's great, but I don't need to see that right now. So, if you have questions and you need help or assistance, send me an email. You know how to reach me. What are we doing tomorrow? Tomorrow is going to be lab-related stuff, as well as a Q&A session, which is the perfect time to ask me questions about like practice problems and stuff. If you'd like, we can also go over some of the questions from the worksheet. The worksheet does have answers for Units 1 and 2 now. The rest of them don't, but we're not there yet anyway, so it's fine. It's basically office hour. You get to choose how you use that time, but we're going to start with the lab lecture so I can show you all how to do lab stuff then. Okay. But I think that that's everything for today, so we'll put the title card back up. Thanks for watching, and I hope everybody has a wonderful rest of your afternoon. Enjoy the sun, and stay safe, stay healthy, stay at home. Have a good night.